All right, let's take a moment to talk about the difference between the words distance and displacement. These are words that are very similar in common casual conversation. People will probably use them interchangeably as if they have exactly the same meaning. But when we are in physics, it's important that we understand that although these words are very closely related, they technically have two different interpretations. And understanding the difference between the two words is going to be crucial for interpreting the questions correctly so that you produce the correct final answer. So let's talk about distance to start, because this is a word that you probably feel very comfortable with. Distance is basically a way of saying how far. So it says here that our distance is going to be the total amount traveled. How far, we know, means that something has moved. So from here to there, how far is that? But I put the word total in as part of the definition because I feel like that's going to be helpful when it's time to interpret questions, that we automatically remind ourselves that it is a total. So if we have an object that has moved from one location to another, obviously that's a how far, but what if it went 2 or 3 different places? If the question is asking us for the distance, let's say that it moved 2 meters in the first segment, and then it moved 3 meters in the next, so now we're up to 5, and then it moved another meter. Well, our distance is going to be 6 meters because by definition, I'm just going to add up all of those segments. It says in the description here that distance is a scalar quantity. And so we should already understand that direction is not important. So if specifically we have an object that's going to travel 2 meters north, and then say that object goes 5 meters south, and then from here, the object is going to go 1 meter north. Well, if we wanted to know the distance traveled, I would just add up 2 plus 5 plus 1 for a total of 6 meters. Now, this is exactly what your car's odometer does whenever you drive around. So this is an example I want you to be familiar with, okay? The odometer reading on your car's dashboard says how many miles that car has traveled. The odometer only counts up. It will never count backwards. So if you are traveling north on the highway and then you exit and go east, and then you make a turn so that now you are going south, that directional change does not affect the fact that your car's odometer is just tacking on, we've gone another mile, now we've gone and traveled another mile, now we've gone another mile. If your car is in drive versus your car being in reverse, your odometer is counting 1 more mile, whether you're traveling in the gear of drive or reverse. So when we say distance is going to be what our odometer shows you, if maybe that real life comparison is helpful, then please make a mental note of that. And again, this is an example you will need to be familiar with. So distance is scalar. It's how far. Direction is not important. If we're talking about our displacement is going to be represented by a how far, but it's a very specific from your very first position to your very last position. So displacement, it says, is a straight line drawn from the initial position to the final position. So we will talk about expressing this in an equation in more detail in a future lesson, but for right now, I want you to maybe simplify this and say that displacement expresses our change in position. So we're going to need to know what the 2 locations are that we are measuring between in order to determine what our displacement is. So let's pause for a second and let's look at the notations that I have on the screen here for how we would express our displacement. Our displacement could be expressed with just the plain old letter d, and we'll actually use d for both distance and displacement in our equations. It could be expressed with an x, which we will use in later chapters, or it could be expressed with this symbol here, which looks like a triangle D, but the way that we're going to say this is we're going to call it a delta D. If you have not had experience with delta in your math class, then I want to make it very clear to you. This triangle is pronounced delta, and it specifically means change. So anytime you come across this symbol in my class, we're always going to say it as delta, and the meaning behind that is a change in whatever variable we're dealing with. So right now, if we see a delta D, that's going to be a change in our position, and we're going to have other delta variables later, and we'll elaborate on that as they come up. But delta means change. So we are going to interpret our displacement as the change in position. So that means I need to know what my positions were. The example that I have here on the screen is yardage gained, and technically it's yardage gained or lost in football. If we're watching a football game and the ball starts on the 5-yard line, and then the play ends with the ball on the 10-yard line, well, we would say that there were 5 yards gained on that play. Or maybe in the books, it would go down as a positive 5 yardage, right? If we have a play where the ball starts on the 5-yard line, but let's say there was a loss on the play, so the ball went down on the 3-yard line. Well, now what we would say in football is that there was a loss of yardage of 2 yards. What would go down in the books would be a negative 2 yards, right? So if you've ever watched a game and a team has negative yardage, that means they're moving the wrong direction on the field instead of going the correct direction, right? That's a bad game right now if we're in negative yardage. So when we talk about displacement, we can have either positive or negative numbers because it's from beginning to end with that direction in mind. So it says here that displacement is a vector quantity. We've talked in a previous lesson about how all variables that are vectors can either have positive or negative values. If we look at the example on the screen down here, if I'm talking about displacement for this segment, this would be however many miles southeast of where we started. We're going to include that directional piece. So when we say from initial position to final position, it is a vector value. That's what we mean. Now we're asking a question here. If you run 1 lap around the track, what is your distance? Remember, your distance is your total yardage. So if you're not familiar, if I start here, 1 complete lap around the track, that's 400 meters. But if it's asking me for my displacement is going to be where I started compared to where I ended. And since it's the same place on the track, that would be an answer of 0 meters. This is not a trick question. This is a vocabulary question. So make sure you know the difference between the two. Here, I'm simply wanting to illustrate just a different example of how we would go about calculating our distance versus displacement. So you can take a moment and you can look at the illustration and see that we have a total distance of 19. Obviously, that's from adding up all of the different segments, but our displacement here would be 14 meters. Now, how would we come up with that number? In a situation like this, our displacement is a straight line, and it is from beginning position to ending position. So sometimes I say from point A to point Z, right? That final position, whatever that location may be. But in this case, because it came up to be a diagonal, we would have to do that right triangle math that we've talked about in other lessons, where we would need to know how much of this diagonal is horizontal, how much of this diagonal is vertical, and we do some a squared plus b squared equals c squared to figure that out. Now it says down here, displacement is always either equal to or less than our distance. Our displacement most often is going to be less than the distance. What's the only time that it would be equal to or the same as? The only time it would be equal to it is if our initial motion was along a straight line path. You should know by now the shortest distance between any 2 points is a straight line. Make sure you know the difference between distance and displacement, and please note that both of them are measured in meters.